In this video, we're going to talk about something called discrete random variables. First off, what do we mean by random variables? This is a variable whose value depends on a random experiment. So let's say it's a variable x, and x is going to be the number of times you flip a heads when you flip a coin 5 times. So x could be 0, maybe you get all tails. X could be 3, maybe you get 3 heads and 2 tails. X could be up to 5, so x can be anywhere 0 to 5, and its value depends on the random experiment of flipping a coin 5 times. So that's a random variable. Now a discrete random variable for us is just going to mean a variable that only has a finite number of different possibilities. So in that case, x could be 0, 1, 2, 3, 4, 5, and that's all x can be. So that's going to be a discrete random variable is a variable that can only have a finite number of possibilities. Now we're usually going to describe a discrete random variable with something called a discrete probability distribution. And all that's going to mean for us is a table, and the table is going to include the different x values you can have along with their probabilities. And those probabilities have to satisfy 2 conditions. One condition is that all the probabilities have to be between 0 and 1. Right? You can't have a probability that's negative. You can't have a probability that's more than 100%. And if you add up all those probabilities, you have to get a total of 100%. So those are the 2 rules for any discrete probability distribution. For example, let's say you're playing a game and you might lose $5, and this happens, I don't know, 40% of the time. Or you might win $1 and this happens 30% of the time. Or you might win $10 and this also happens 30% of the time. So this is just a way of describing this distribution where you have the value of x, how much money you win, or in the negative case, lose. And then next to it is going to be the probability of each one of those things. And that's a discrete probability distribution. You can check each one of those probabilities between 0 and 1. And if you add them up, you get a total of 1. Notice that we don't care about the value of x. The value of x can be negative. The value of x can be more than 1. That can be whatever number you feel like putting there. It's the probabilities that have to be between 0 and 1 and add up to 1. So keep that in mind. I've seen a lot of confusion in the past over that. You're adding the probabilities and getting 1. You are not adding the values. In fact, you are never going to add just the values here, the negative 5 plus 1 plus 10. Don't ever do that. There will never be any circumstance where you're just going to add those x values there. You will occasionally add the probabilities. And there's also something else we're going to do in the next section here called the mean. So we saw how to calculate mean when you have a data, right? A bunch of sample data values. You add them up, divide by how many there are. So way back when we had this formula, and then we had the sample version of it. And then we also had the weighted average, where you multiply the value times the weight. Now what we're going to do is we're basically going to use the weighted average now, except realize that instead of a weight, we're going to put a probability here. And what happens if you add up all the probabilities? Well, that's just 1, so it doesn't really matter if we divide by it or not. So that means the formula for the mean of a random variable is you're going to take the value of the variable, you're going to multiply it by the probability, and then you're going to add those things up. And that is going to be the mean of your discrete random variable. Now, let's go ahead and calculate it for the example I already have on here. Now, I said we're never going to just add the values here. What we are going to do is we're going to multiply the values times the probabilities and then add those results up. So I would take the value of negative 5 times the probability of 0.4 plus the value of 1 times the probability of 0.3 plus the value of 10 times the probability of 0.3. So you multiply them first, and then you add them up. Then we say negative 5 times 0.4 is going to be negative 2. 1 times 0.3 is 0.3. 10 times 0.3 is 3. So then we go ahead and we see this here and we add up. So 3 minus 2 is 1 plus that. We're going to get a mean of 1.3. So this is how you're going to calculate the mean of a discrete random variable. I will point out yet again that this can be done in your calculator without doing the work yourself. And I will have a video showing you how to do it in your calculator. But for a moment, let's stop worrying about the calculation and try to understand what this value means. So if you think about it, when you're playing this game, sometimes you're going to lose $5, sometimes you're going to win $1, and sometimes you're going to win $10. If I wanted to describe what happens on average, or what can you expect to happen, that's what this mean is. Here's 1.3. That means on average, you're going to win $1.30 per game. Now, if you look at the game here, you can't win $1.30 in a game. You can either lose 5 or win 1 or win 10. Never ever are you going to play a game and win $1.30. But this is saying that on average, if you were to keep playing this game over and over and over again, let's say play it 1,000 times or 1,000,000 times or however many you want to, that on average, if you take your winnings and losses and you balance it out, it's going to end up being a net gain of about $1.30 per game you played. So if you ended up playing 10 games, you'd expect to be up about $13. That's 10 times 1.3. If you played it 100 times, you'd expect to be up about $130, which is 100 times 1.3. If you played this game 1,000 times, you'd expect to be up about $1,300. And that means, again, 1.3 times 1,000. Now, you are never guaranteed that to happen. This is just the average of doing it a whole lot of times is what you expect to have happen. Because even though it's a positive number here, I said in 10 games, we expect to be up about $13, that doesn't guarantee it. You could have actually lost all 10 games and be down 50. That could happen. You could have had an unlucky streak, and that's what it is. So never think of the expected value as any type of guarantee. It's just saying in the long run, you expect things to balance out to this. That's what the expected value is. And I want to point out something here, that if the expected value, if you ever calculate it and you get a negative number, that means you expect to lose money on average. Whereas if you get a positive number for your expected value, you can expect to win money on average in the long run. And guess what? If you were to do this calculation for all those casino games out there, pretty much every casino game you're ever going to come across is going to have a negative expected value. That means that if you're going to the casino and you're playing games, you can expect, on average, to lose money. Sure, maybe sometimes you'll make money, maybe you even get a jackpot sometime, but if you keep playing, you can expect to lose money over time. Doesn't mean that, casinos are worthless, you can have fun doing it, and some people are okay, but don't ever go there expecting to win money, because they design the games in such a way that you have a negative expected value so that you are losing money on average. That's the whole point of casinos, for them to take your money. One last thing before I go about the standard deviation is if the mean is 0, then it is called a fair game. So whenever I use the terminology fair game, I mean that if you do this calculation, you get an expected value that is 0. That's all I need to say there, because that means that you're not winning money or losing money in the long run. It's kind of balancing out perfectly. Okay, the last thing here, and it's not something we're going to use very often, but I will go ahead and tell you, and that's the standard deviation of a discrete random variable. right? Think back to before we learned about mean for samples and population, and we learned about standard deviation for population and samples. Now we're going to do standard deviation of these discrete random variables. And the formula for that, you can either do it with the variance or the standard deviation. The variance is going to be the sum of x squared times the probability minus the mean squared, or if you want to square root that whole thing, that will give you the standard deviation. And again, there's really no need for us to calculate it by hand. When you're putting in the data in the calculator and you hit calculate, it's going to give you the mean and it's going to give you the standard deviation all in one go. There's no need to do it by hand. But if you wanted to, just to see how it works, for the case that we have up here, so you take the value of x, you square it, you multiply it times the probability. You take the value of x, you square it, you multiply times the probability. You take the value of x, you square it, you multiply times the probability. You subtract the square of the average, and then you square root the whole thing here. So let me get out my calculator here. So this first one, negative 5 squared is going to be 25 times 0.4 is 10. Plus 1 times 0.3 is 0.3. Plus 100 times 0.3, that's 30, adding up to 40.3, minus 1.3 times 1.3, and I'm getting 38.61. And if I square root that, I get a standard deviation of 6.2, let's say. So if you think about it, the standard deviation tells you how much you can be off from the average. And this is a relatively large number, right? We're saying we win $1.30 on average per game, but plus or minus $6.2. That's a pretty big swing, and even going one standard deviation to the left, you're already negative. So this is why, you see this big standard deviation means there's going to be a lot of variance as you're playing the game. Who knows if you're going to end up being up or down after, say, 5 or 10 hands. Because there's a lot of variance here, you might really easily have a bad streak and lose a bunch of money. So keep in mind, we have discrete random variables. You should know what they are, and you should be able to use your calculator to get the mean and the standard deviation for those discrete random variables.